Welcome everyone. In this video, I'll go through an A-level chemistry exam question that involves the Gibbs equation and feasibility. Details are in the description. Let's get started. Here's the question. Use the data to show that this reaction is not feasible at 298 Kelvin. We're given a balanced equation for the reaction and the standard enthalpy change is equal to plus 337 kilojoules per mole. We are also given a table showing the standard entropies of the substances involved in the reaction. To answer this question, you have to know the Gibbs equation. It will not be given to you in the exam. Delta G is equal to delta H minus T delta S. Delta G is the change in Gibbs free energy. Delta H is the enthalpy change, T is temperature, and delta S is entropy change. We can work out the standard entropy change using the data from the table. To do this, subtract the sum of the entropies of the reactants from the sum of the entropies of the products. We have to take into account the balancing numbers, the stoichiometric coefficients. For example, the standard entropy of iodine is multiplied by a half. The entropy change for the reaction works out to be plus 11.3 joules per mole per Kelvin. Take care with units. We are given the enthalpy change, delta H, in the question, plus 337 kilojoules per mole. We are also given the temperature, 298 Kelvin. We must be consistent with units. Either convert delta S to kilojoule per mole per Kelvin by dividing by 1000, or convert delta H to joules per mole by multiplying by 1000. Temperature must remain in Kelvin. If you were given a temperature in degrees Celsius, you would have to convert this to Kelvin by adding 273. I chose to convert delta S. Substituting the numbers gives a value of plus 334 kilojoules per mole for the Gibbs free energy change. If I had converted delta H to joules per mole, the Gibbs free energy would work out to be plus 334,000 joules per mole. Units are essential. Finally, to address the question, a reaction is feasible if the Gibbs free energy change is less than 0. Delta G is greater than 0, therefore the reaction is not feasible under these conditions. Thanks for watching. I hope you found the video useful. Please post any comments if you have any questions or suggestions. Take care and good luck with your studies.